Hello everybody and welcome back to the continuation of our actual server.c coding. So what we did by now is we coded the main function right here and we came to the actual while true loop, which is going to belong to this main function after accepting the actual connection. So the first thing that we need to do is we need to think, what do we want to perform in this actual while true loop? So we once again want to perform the actual sending of a command and receiving back the result. Since this is an actual server, we need to prompt the user of this server first to input the actual command, such as for example the command can be ipconfig, whoami, or so on and so on. And then once the user inputs the command, we send that command to the actual target. So the first thing that we are going to do is we're going to clear the actual variable that is going to accept the actual buffer or the actual command. We're going to p0 it, so basically we will overwrite it with bytes, with 0 actual bytes, so with zeros. So we're basically going to overwrite it with zeros, just in case. At the beginning of the while true loop, we're going to type the memory location of the buffer, because that is going to be the actual variable that we're going to use. As we can see right here, we defined it to be 1024 bytes. Now we're going to clear all of those bytes at that memory location. If there is anything else but zeros, we want to make sure there are only zeros. So we need to specify the memory location of the buffer, which we specify like this, and then the size of the actual buffer, so that we know, so that the function can actually know how many bytes it should clear with zeros. Okay, so that is the beginning of our while true loop, and also we want to do the same thing with the actual response. So the response is the actual variable that is going to store the result of, for example, ifconfig that the target is going to send back to us. For example, let's say we run whoami, and then we send that command to the target, and the target in its actual system runs whoami. The output is root, then the target sends back root back to us. That root actual result is going to be stored in this actual response. So we want to clear that as well with 0. So at the memory location of the response, and then comma size of the actual response. And we're going to do that at the beginning every time of the while true loop. So make sure that you specify it at the beginning. And right now we are ready to actually prompt the user for the command to input it. So printf. And right here, let's call it something like this. Let's add a star shell, and then, for example, hash, and then %sign s. And the reason we are using this is I will show you in just a second. So $sign and then 2 dots. So this is something that we're going to print, and instead of this %s, we're going to print the IP address. So in order to define that, we simply just add comma after this printf. And once we close the double quotes, we specify comma, and then we're going to use a function that is going to convert the IP address into an actual string. So we're going to use inet_ntoa, and we're going to perform that under the actual variable that is storing the IP address. And the variable that's storing the IP address is right here. So we're going to perform the actual conversion of this IP address into a string onto this variable, because this actual variable stores the IP address. So we need the same actual variable that stores the IP address of the actual client or our target. So we know that it is accepted inside of this actual client address right here with this function. So we also know that the actual same part should be considered to host the IP address of the client. So we need to call something like this. So client_address and then syn_addr. And this part right here should actually store the IP address of the client, because it is accepted right here. And this actual part right here should be the one that is storing the IP address. If it is not, we're going to have to change it. But for now on, we're going to leave it like this, add dot and comma. And right now, we are ready to actually take an input. So all we did right here is printed this, and now the target is the actual server is waiting for input from the user. So we're going to use a function called fgets. And if you see right here, if I go to the actual Google Chrome and we simply just type fgets in C, you will see fgets is a function in C programming language that reads a limited number of characters from a given file stream source into an array of characters. fget stands for file get string. It is included in the C standard library header file stdio.h. So fgets stands for file get string, basically from a source of actual stream, we need to get an array of characters, as it says right here. So basically it is taking a user input, in other words. So we want to take that user input and store it into a buffer. We need to specify the actual variable name as well as the size of that variable, which is 1024 bytes, but we're simply just going to specify size of buffer. And then we're going to take the actual stream of characters or the actual input from the standard input, which means from our simple command line. So right here we simply specify std_in, because the reason why we need to specify this is because the fgets can also be used to store, for example, the characters from a file. Therefore you would specify right here something else instead of the std_in, but we're getting the actual input from the console. That's why we need the standard input. Cut the new line character from our buffer once we actually get the input, because once we actually get the input and we type, for example, who am I, it will also add a new line character to the actual buffer. Therefore it will send the who am I command with a new line character, which is the \n, to the target, and the target will try to execute this command, which is who am I, and then \n, and it will not know what this actual command means. Therefore it will not execute it properly. That's when we need to actually get rid of the new line character from our buffer. That's why we're going to use a function which is called strtok. And basically that stands for, I forgot what it stands for, but it will simply just cut the actual new line character from our string. So we specify buffer and then comma, and at the second spot comes the actual thing that we want to get rid of in the actual string. So we want to get rid of a new line character, so \n, and then we simply add dot and comma. And the next thing that we need to do, send the actual command to the target. So we are going to do that using the write function, and write is same as send, but in a little bit easier syntax. So we're going to use the write function to send the actual command to the target, and the actual parameters that we need to specify in the write function are the client socket. So client socket is the first parameter. Then the second parameter is the actual command that we are sending, which in our case is stored in a buffer. And the third actual parameter is the size of the command that we are sending, or the size of the variable. In this case, it is going to be the size of buffer. And now we send the actual command back to the target, or not back, we actually sent it for the first time to the target for it to execute it and then send back the results back to us. But one thing that we're going to add before the actual write command is we're going to check whether our command was clear. So for example, we ran a bunch of the commands and we want to clear the screen. The same thing you do in a terminal. Let me just show you right here. I will simply just save this. And let's say we run a bunch of the commands and we type then clear, and it will clear the screen. So we want to implement something similar to our actual backdoor or malware in this case. So we're going to have to execute it before sending of the command, because we don't want to send the clear command to the actual target. For the clear command, we only want to execute it on our own system so it can clear our own terminal. We are not interested in clearing the terminal of a target. Therefore, we need to execute it before actually sending that command. Or in this case, we don't actually want to send it at all. So right now we are running into a problem how we can do that. So I need to actually find a way how I can compare the buffer with a specific command. But I don't want to actually compare it entirely. So we know that the buffer, right now we want to actually compare the buffer with a clear string. So we are sending simply to the target this string, so clear, which is a command that clears the screen. Or pardon me, we're sending to ourselves the actual clear command, but we also want to compare it with the buffer to see whether that is something that the user of the server inputted. So how we can do that? Well, there is an actual function in C called strncmp, and what this function does is basically it compares two strings. But it takes an actual input of 3 parameters. The first parameter is the actual string that we are searching for in the actual buffer. So in our case, we are searching for clear. The second parameter is actual variable from which we are reading the actual input, which is buffer in our case. So we are comparing these two. If buffer equals to clear, then we are going to clear our own terminal. But you will notice that the buffer is a size of 1024 bytes, while the clear, therefore the third actual element or the third parameter to this function we need to specify is how many bytes are we comparing. In our case, we are comparing 5. So we're going to add this to the actual program if and then string or strncmp from the clear at the first parameter, buffer at the second parameter, and 5, because we are comparing 5 bytes at the third parameter, is equal to 0, because if you search the strncmp in the actual Google search bar, you will notice that this actual command, once you open some page, will return a value of 0 once it performs correctly. Okay, so once this actually does match, so the first 5 bytes of buffer match the actual first 5 bytes of this string, which is clear, then we will return a value of 0, and then we can execute the actual command. If they don't match, it will skip this, because then the user haven't inputted the actual clear command. They inputted something else. Okay, so first thing, if it is equal to 0, then we are going to open the curly brackets, because we need them in an if statement, and we're going to call this system and execute the actual command clear. So this simply will just execute the clear command in our own terminal, clearing our own screen in the Kali Linux machine. But right now we are running into a different problem, and that problem is, as soon as this executes, it will go to this line and not at the beginning of the actual while true loop. Therefore, it will actually send this command to the target, and then the target will bug out, because they don't know how they can clear their screen on a terminal that isn't even opened. Therefore, we need to find a way how we can actually go to the beginning of while true loop after executing this if-else statement, and not going all the way down and then at the beginning. Now, in actual C, we can use something called a jumper, or we're just going to call it jump in this case, and add 2 dots at the end. What this simply does is, it is something similar to actually jumping from the lower actual row to the upper row. It is used in assembly as well, but in this case we're going to use it like this. So we are typing it at the beginning of our true loop, and then we're going to use it in our if statement and go and call the goTo function, which is going to go to jump. And therefore, after executing this actual if statement, it will run onto this actual statement right here, and then it will go to jump, and then it will go to the beginning of the actual while loop. Okay, so that is also something interesting to actually know, because otherwise we wouldn't be able to actually make it not execute this. So we are good to go. Right now we set up the actual if statement, which checks for clear command, and right now if the actual command wasn't clear, we want to actually send the command to the target. And now after we send the command to the target, we need to check for some other specific commands. So if string compare, and let's say that the target executes Q, the user inputs Q as a command, that will be indication for the actual user that they want to quit the connection. Therefore, we're simply just going to actually quit the connection. So first of all, we're going to compare the buffer with Q. So we need to specify 1 byte. We're comparing first 1 byte because Q only has 1 letter in it. Therefore, it is only 1 byte large. And if that is equal to 0, now keep in mind you need to specify 2 equals in comparison and 1 equal to define. Therefore, you need to specify 2 equal to actually check whether it is equal to 0. And if it is equal to 0, we're simply just going to open these curly brackets and break out of this loop, closing this program. Because if the actual user of server specified Q, they want to quit the connection, they want to close the actual program, and we will simply just break out of this while true loop. Okay? And now else if, so in other case, so else, and let's open these brackets, else we want to actually execute the command that the user sent to the target. And how we can execute that? Well, we can execute it in an actual payload that we're going to code in the next lecture, and right here we can only accept the actual response from the actual target. So in order to actually get the response from the target, we are going to use the receive function, and that receive function takes 4 parameters. In this case, it takes from which target are we receiving. We are receiving from the client socket, so client underscore socket we are going to store it into response variable. So this is the usage of the response variable to store the actual response from the target. We also need to specify the size of that variable. So we are going to use the size of function, so size of response. And at the last parameter, we are going to specify message or MSG underscore wait all. And if you go to the actual Google Chrome and type MSG underscore wait all, see, you will notice that the actual receive function at the fourth parameter can take these actual arguments, and we out of all of this set to actually wait all, so MSG wait all, and it says right here, this flag requests that the operation block until the full request is satisfied. However, the call may still return less data than requested if a signal is caught, an error or disconnect occurs, or the next data to be received is of a different type than the returned. This flag has no effect for datagram sockets. So what it says right here, this flag has no effect for datagram sockets, is for the UDP connection, but since we are going over TCP, we specified this to wait for all of the data or until all of the data is received, and then they can proceed to the next actual command, which is going to be printf, and we want to print the data. So we're going to specify %s, and then comma, instead of that %s, we want to print the actual response. So we are converting the actual response to a string, and therefore we're printing the string value of the actual response. Okay, and outside of the actual while true loop, if we perform this break statement right here, we want to close the client socket first, and right after that we want to close our own socket, and therefore closing the entire program. So for now on, this is the actual entire server that we need. We simply coded the entire while true loop. Now we're going to need another actual else if statement, but we're going to code it later on and not now. For now on, this will be more than enough. So in the next tutorial, we're going to start coding our actual backdoor or malware, and you will see that the code differs a little bit because we're going to code it for Windows, while this server was actually coded for Linux because we are going to run it in our Kali Linux machine. So I hope you enjoyed this tutorial, and I hope I will see you in the next one. Bye!